On any given day, the most expensive weapons program in human history cannot fully do its job. Not 10% of the time, not 20% of the time, 63% of the time. The plane that was supposed to replace everything the United States Air Force, Navy, and Marines fly cannot complete its full range of combat missions. The program has cost $2 trillion. It has been running for 23 years. And in March 2024, the Pentagon approved buying more of them. In 2001, Lockheed Martin won one of the most ambitious military contracts ever awarded. The pitch was straightforward. Build one fighter jet that could do everything. Replace the F-16, the A-10, the FA-18, and the Harrier jump jet with a single aircraft available in 3 variants for the Air Force, the Navy, and the Marines. Sell it to allies worldwide so the development costs could be spread across multiple countries. One plane, every mission, shared cost. The program was called the Joint Strike Fighter. The jet would be designated the F-35 Lightning II, named after the legendary World War II fighter on purpose. That confidence was intentional. The technology inside the F-35 was genuinely revolutionary on paper. It promised stealth coating that would make it nearly invisible to radar. Sensor fusion combined information from multiple systems into a single display, giving the pilot a complete picture of the battlefield that no previous fighter could match. It included a helmet that cost $400,000 per unit, more than a Ferrari, that allowed pilots to look through the aircraft by projecting camera feeds onto the visor. 19 countries eventually signed on. They included the United Kingdom, Australia, Japan, Israel, Norway, Denmark, and the Netherlands. All of them committed billions of dollars based on a single promise. The total cost would be $233 billion. First planes were to be delivered by 2010, fully operational by 2012. Those numbers were wrong in ways that would take 2 decades to fully understand. The decision that turned a difficult program into a catastrophe was made early, and it was made deliberately. It was called concurrency. In a normal weapons program, you design the weapon, test it fully, fix every problem you find during testing, and then begin mass production. Concurrency reversed that sequence. The Pentagon decided to begin building and delivering F-35s to customers at full production speed while the aircraft was still being tested and redesigned. The logic was that starting production early would drive unit costs down faster. The reality was that every problem found during testing now had to be fixed on planes that were already built, already delivered, and in some cases already flying. In 2011, the program's own commander, Vice Admiral David Venley, admitted on the record that concurrency had been a miscalculation. The Government Accountability Office had warned about exactly this risk in 2006. The program continued anyway. By the time testing was finally completed in 2024, more than 990 planes had already been built. Every defect found in testing represented not just a design problem to fix on future production, but an expensive retrofit that had to be applied to hundreds of aircraft already sitting in hangars around the world. That single decision, building before testing was finished, is the primary reason the program went from $233 billion to $2 trillion. When the F-35 entered formal operational testing in 2018, the documented deficiency list had 873 items. 13 of those were Category 1 deficiencies, meaning they directly affected safety or combat capability. The Pentagon declined to publicly release what most of the deficiencies were, citing operational sensitivity. What did become public was enough. The internal gun on the F-35A was inaccurate. The aircraft designed to replace everything, including the A-10 Warthog with its devastating ground attack capability, had a gun that missed its targets. That problem was not fixed until 2024, 23 years into the program. The cockpit pressure regulation system caused pilots severe sinus and ear pain during certain maneuvers. The radar could not scan as wide an area as required by the specification. The night vision camera displayed green horizontal lines across the image. The ejection seat, at certain pilot weights, had a 23% chance of killing the pilot on ejection and a 100% chance of injury. The Pentagon's response was to set a minimum pilot weight and keep flying. The stealth coating that made the F-35 nearly invisible to radar could not survive extended supersonic flight. The heat generated at high speed damaged the coating. There are classified restrictions on how fast and how hard pilots can push the aircraft in training, and those restrictions are not publicly discussed. The logistics software system, originally called ALIS, and later replaced by a successor called Odin, could not reliably distinguish new parts from old parts. It randomly locked users out of the system, and it continued failing with each software update for years. The cost numbers tell a story of their own. $233 billion in 2001, $406 billion by 2017, $2 trillion through 2088. That is a 630% increase from the original estimate over the lifetime of the program. The Block 4 upgrade, the software and hardware modernization package that was supposed to bring the F-35 to its full intended capability, was originally budgeted at $10.6 billion. The current estimate is $16.5 billion, and full delivery has slipped from 2024 to sometime in the 2030s. Every year the program runs late. Every retrofit applied to planes already built, every software patch that fails and has to be rewritten, adds to a bill that is now so large it spans generations. People who have not yet been born will be paying for this program. The readiness numbers are the part the Pentagon does not emphasize in press conferences. According to analysis of Department of Defense data, the F-35 fleet as a whole can only perform its full range of combat missions approximately 30% of the time. The F-35A, operated by the Air Force, has a full mission-capable rate of 36.4%. The F-35B, operated by the Marines, sits at 14.9%. The F-35C, operated by the Navy, is at 19.2%. On any given day, 4 out of 5 Navy F-35 aircraft cannot do everything they were designed to do. The military responded to these numbers not by fixing the planes faster, but by flying them less. A Congressional Budget Office report in 2024 confirmed that F-35 aircraft will fly 21% fewer hours going forward due to reliability issues. Fewer flight hours means less wear. Less wear means lower maintenance costs in the short term. It also means pilots flying fewer hours in the aircraft they would take into combat. The question of what the F-35 is actually worth as a combat aircraft is genuinely complicated by the fact that it has been used in real combat. Israel has used the F-35 in strikes over Syria since 2018, and the aircraft performed. The stealth worked. The sensor fusion worked. The United States used F-35 aircraft in strikes against Houthi targets in Yemen and in operations against Iran in 2025 and 2026. In those engagements, the plane did what it was designed to do. But every one of those missions was a controlled strike against adversaries with limited air defense capability. Exactly the conditions where an advanced stealth aircraft should perform. The open question, The one nobody in the Pentagon will answer directly is what happens when the F-35 needs to operate in a sustained, high-tempo conflict against a peer adversary. Against China over Taiwan. Against an opponent with modern air defenses, electronic warfare, and the ability to shoot back effectively. In that scenario, a fleet where less than 20% of Navy aircraft are fully mission-capable on any given day is not a small problem. It is a strategic vulnerability. In 2015, the Pentagon ordered a direct performance comparison between the F-35 and the A-10 Warthog for close air support missions. The A-10 is a 1970s ground attack aircraft. It costs $20 million. It carries a 30mm Gatling gun originally designed to destroy Soviet tanks. It is not stealthy. It cannot supercruise. It was supposed to be replaced by the F-35. The results of the fly-off comparison were not released publicly. Internal accounts that later emerged suggested the F-35 did not clearly outperform the A-10 in the mission the A-10 was specifically designed to do. The A-10 is still flying today. On March 12, 2024, 23 years after the contract was awarded and 5 years past the original target date, the Pentagon approved the F-35 for full-rate production. The approval came weeks after a testing report that cited ongoing failures to meet availability, reliability, gun accuracy, and stealth requirements. That report was classified at a level that prevented congressional staff from reading its conclusions. The people whose job it is to approve the funding for this program did not have the clearance to read the document that described what was still wrong with it. Full-rate production was approved anyway. 990 planes had already been built. 2,470 more are planned for the United States alone. The program will run until 2088. The F-35 is not a failed aircraft. It has flown combat missions, and it has performed. The stealth technology is real. The sensor fusion capability is genuine. In the right conditions, against the right opponent, it is probably the most capable strike aircraft ever built. But the program that produced it made a decision in its earliest years to build first and fix later. That decision compounded every problem that followed. It turned a difficult program into the most expensive weapons acquisition in human history. It produced a fleet where the majority of aircraft cannot fully do their jobs on any given day. It generated a testing report so sensitive that Congress was not allowed to read it before approving continued production. $2 trillion, 23 years, still not fixed. The Pentagon classified the document that said so. That is not a rumor or a leak. It is in the Congressional record.